Okay, today guys, we're going to talk about logarithmic functions, and there is something very important that you need to remember. That is that the answer to a log is an exponent. That means your log, when you say equals, it will be an exponent on the other side of the equals mark. The answer to a log is an exponent. Okay, one of the things that we're going to have to do today is to change forms. We're going to be talking about log form, and we're going to be talking about exponential form. Okay, so when something is in log form, you will see a log, a base that is on a lower line. Okay, it is a subscript. And then what you have here, where I have an A, will be your answer. That's why I'm using A. And then when it's equal to, that's where I have the X. That's going to be your exponent. What I'm saying is, in exponential form, over here on the right, I have basically the same thing turned into exponential form. B is your base, X is your exponent, A is your answer. So when you're trading back and forth between these two forms, the base is either here in an exponential form or here in a log form. The exponent is what it's equal to in log form, but it is actually an exponent in exponential form. Then your answer in exponential form is found here in the log form. So those two things are related, and what we're going to be doing is changing back and forth between those at some point. Okay, another important thing to know is that if there's no base shown, if they don't have a number written as a subscript, then it's understood to be 10. So if no B is shown, then you know that the base is 10. They don't necessarily write the 10. Okay, we're also going to work with natural logs, and the way that those are different is that they just write LN instead of LOG, but they do that to let you know what I have down here in orange. If they're using natural log, then your base is understood to be E. Just like here, if they don't write a B, it's understood to be 10. Here, it's understood to be E every time. Your answer, what would be your answer over here, is still right here. Your exponent is still what this is equal to. So in exponential form, this would be e to the x equals a. Okay, so here are some examples where we're wanting to change it from log form to exponential form. And all the pieces are here, you just have to put them in the right place. So for number 1, I first identify the base, which is this 3. And so that's going to be my base over here. And then I go to the exponent, which would be located here. So that would be 3 cubed equals. And then the answer to my question over here is right here. It's located where this 27 is. So 3 cubed equals 27. And this should make sense because 3 cubed is 27. So we've just changed it around and made an exponential statement out of it instead of a logarithmic statement. Okay, for example 2. Again, I want to locate my base first, which will be 2. My exponent is what is over here to the right of the equals mark, so it'd be a negative 3. And then my answer to my exponential would be the 1/8. And again, this makes sense because 2 to the negative third, the negative means we're moving to the bottom of the fraction. The cube part, 2 cubed is 8. So this statement makes sense. For the third example, I used a natural log. And so you have to remember that although they don't write the base there, the base on a natural log is E. So E, my exponent is 2, and then my answer is the 7.389. Just rearranging that statement. Okay, you're also going to be able to go back the other way. So for the next 3 examples, I chose to go to log form. You're given exponential form. So you want to, first of all, look at the base. Since this is a number, 3, I know I'm going to be using a log, regular LOG. And then I am going to look at that base and make sure I put it as a subscript, so base 3. The answer to the problem will come next, so the 81 will come here. And then the exponent on the problem is what this answer is, so 4. So there is my fourth example. For example 5, again, because the 16 is a number and not an E, or I mean a 10 is a number, but we could look at that a little differently by leaving it off. Since it's a 16, I need to make sure it's a subscript. So log base 16 is how I'm going to start. The answer to this comes next, so 1/8. And then the answer to my log is the exponent for my exponential, so -3/4. So again, just rearrange it in the correct order. For the last one, again, I've chosen one that's a little different because of the E. Since it's base E, I don't use log, I use ln, and I don't put an E as a subscript. I follow with my answer of 20.08, and then it should equal the exponent for the problem, which is 3. Okay, another type of problem that you're going to see is when they say evaluate without a calculator. That means you should be able to do the math in your head. This one, number 7, f of x equals log base 4 of x, and x is 64. The first thing that you need to do is plug that in. So you have log base 4 of 64. Then think about that in exponential form. 4 to what power that we don't know is 64. And you should be able to just think, okay, 4 to the first power is 4. 4 squared is 16, and so on. When you get to the third one, 4 cubed is 64. So the answer to the question is 3, because it would be the third power that would get you there. Another example, number 8, is this one here. Log base 3 of x, x is 1/27. Plug it in first. So you have log base 3 of 1/27. Then think, 3 to what power is going to give me 1/27? Well, first just think about the relationship between 3 and 27. That is 3 to the third power. 3 cubed is 27. What would put it on the bottom of a fraction? A negative. So the answer to this would be -3, because 3 to the -3 would be 1/27. So your answer is going to be this exponent. Again, the answer to a log is an exponent. Okay, another type of problem that you might see is ones where they ask you to solve for x, but it's simple and can be done in your head. There are more complicated ones that we'll be doing on a different lesson, but the ones that you see today, something is easy about them, so look for it. The first one, natural log of e squared equals x. And so again, I want you to think about it in exponential form. The base is e, even though they don't write it here. The exponent is x. And the answer is e squared. If you just change it into exponential form, you see this relationship. And then obviously, if e to the x equals e squared, then x has to equal 2. So that's another one. It just can be easily figured out in your head without a calculator. Number 10, another example of that. Ignore the blue from Microsoft Word. Log base 4 of x equals log base 4 of 11. Well, they're both log base 4. So you could think about turning them into exponential form, but really it's not necessary. You can just see that if they're both base 4, the x has to equal 11. And then the third one, I again would change it into exponential form. My base is 5, my exponent is x, and then my answer is 5 to the -2. And again, it's clear they both have 5 as the base, so x has to equal -2. Okay, for the last type of problem that you're going to see today, we're going to use the properties of logs to rewrite each expression. And it is going to, again, be something that is involved with the logarithmic or exponential form that we can see. So the first one, 2 is the base, and 2 is in the answer. That's going to factor in. I want you to look at this one like it's asking the question, what is the answer? So if we were to say 2 to what power is 2 to the 5x, you would know the answer. Or again, 2 to what power is 2 to the 5x? I'm just putting it in exponential form. Obviously, this is 5x. So I'm just rewriting it in a simpler form, 5x being the simpler form. My second example, which is number 13, again, I want to think of simplifying this in here. So I'm going to ask, not with the 2 right now, but just with the log base 3 of 1/3. 3 to what power is 1/3? Well, the 3 goes to 3 just by being a power of 1. But to put it on the bottom of a fraction, it would be negative. So the answer to this log is -1. If you replace that and bring down your 2, 2 times -1 is -2. So that simplifies to -2. My next example is very similar. So it's kind of like the first one and the second one. 5 to what power is 5 squared? Well, if you can answer these two, you can realize that it is the exponent of 2. So if I bring down the 6, the answer for this is 2, and 6 times 2 is 12. Okay? The last one over here, it did not show up. I couldn't type it, but this is supposed to be a base of 3 up there. 3 to the log base 3 of 9. And so what I was wanting you to do is to figure out that log base 3 of 9. Ignore the 3 for a second. So 3 to what power is 9? Well, obviously 3 squared is 9. So this answer is 2. So replace this with 2. Now you have a new problem because that was an exponent. And the new problem is 3 from this squared. So 3 squared is 9. That is my answer. So in other words, when you get this type of direction, you should be able to simplify these logs or answer these logs without having to type something in your calculator. Okay. Your work is going to be on page 203. I want you to do 1 through 31 odd and 33 through 42 all.